how to do the Punnett squares practice problems. For every Punnett square, we need to do 5 things. We need to make a key, we need to write the cross, we need to determine the possible allele combinations, we need to make a Punnett square, and then we need to answer the questions. So that would be the genotypes and phenotypes. These are called monohybrid problems. Mono means one, so we're just looking at one trait being passed down to generations. In humans, brown hair, capital B, is dominant to blonde hair, lowercase b. So the first thing we're going to do is we're going to make our key. We have our first choice, capital B, capital B. That is going to be brown hair. As long as we have one capital B, it's going to be brown hair. Our next possible genotype is capital B, lowercase b. That is still also brown. And then the last possible genotype would be 2 lowercase b's. This would be our blonde genotype. Okay, make these red. I would also write homozygous dominant. You need to know these words. So we have our key done. Now we need to do the cross. The cross is going to be from the problem. So it's going to show us in the problem if a heterozygous brown-haired woman. Now heterozygous, the only possible combination is capital lowercase. So we're going to do capital lowercase. And we're going to cross that with a blonde man. So blonde, the only possible genotype is 2 lowercase b's. It's important that you get this right, because if you don't get this right, you're going to fill in the whole Punnett square incorrectly. So I'm going to put one of the parents here, capital B, one letter per box, right? Capital B, lowercase b, and then lowercase b, lowercase b. When we go to fill it in, we're going to drop down the capital B, and we're going to slide across the lowercase b. If you put the lowercase b first, it's not wrong, it just looks weird. Okay, I will not mark that wrong, but please put the capital letter first. We slide down the lowercase b, slide across the lowercase b, and then we've got lowercase, lowercase. Okay, so this is our filled in Punnett square. If you didn't do the outside correctly, then the inside will be filled in incorrectly. For our possible genotypes, we're looking at the 4 boxes inside. So we have one here, capital B, lowercase b. So capital B, lowercase b. We can write it 2 ways. There's 2 boxes, right? So 2 out of 4. So we can put 2 out of 4. Or we can write 50%. 2 out of 4 is 1/2. That's 50%. Our next possible genotype is lowercase b, lowercase b. And we're going to write also 2 out of 4, or 50%. If you wanted to include the one that's not there, capital B, you can. You don't have to. We could say 0 out of 4, or 0%, but you don't have to. When we look at our phenotypes, phenotypes are going to be, what does it physically look like? We only have 2 choices, right? Brown or blonde. So if we look at capital B, lowercase b, we know that that's going to be brown. And we have 2 boxes that will be brown. So we could say 2 out of 4, or 50%. Then we have the other 2 boxes, lowercase, lowercase, that would be our blonde. So we've got blonde, 2 out of 4, or 50%. That's how you solve a Punnett square. Each Punnett square is worth 5 points. 1 for the key, 1 for the cross, 1 for the Punnett square filled in correctly, 1 for the genotypes, and 1 for the phenotypes. What this means is if this man and this woman, right, a heterozygous brown-haired woman crossed with a blonde man, if they have a child, there's a 50% chance that the child will have brown hair, and there's a 50% chance that the child will have blonde hair. Moving on to problem 2. So when we go to do our key, we're using the same problem, right? It's the same key. So I'm just going to go ahead and copy the key, and I'm going to paste it. When we go to do our cross, we're going to look at the problem. So the problem says, if a cross were made between 2 blonde people, So 2 blonde people. If we look at our key, there's only one way to have blonde. That's 2 lowercase b's. So we're going to do lowercase b, cross with lowercase b. That's 2 blonde people. What would be the phenotypes and genotypes of the F1 generation? So F1 is filial 1, that stands for the children. So we're going to fill in our Punnett square. So again, lowercase b, lowercase b, lowercase b. And you should already be able to tell the whole thing is going to be full of lowercase b's. There's no capital B's. Every single box is blonde. So when we go to do our genotypes and our phenotypes, it's going to be pretty easy. So genotypes, we have only one choice, 2 lowercase b's. We've got 4 out of 4, or 100%. When we go to do our phenotypes, again, there's only one choice. So we've got blonde, 4 out of 4, or 100%. Moving on to problem 3. So this is a different piece of information. We can't use the same key, so we're going to make a new key. So in pea plants, being tall, capital T, is dominant over being short. So when we go to make our key, we've got 2 capital letters. That's going to be tall. This is our homozygous dominant. Then we've got capital T, lowercase t. That will also be tall. This is our heterozygous. And we've got 2 lowercase t's. This will be our tall, or not tall, short. This is our homozygous recessive. So the key will help us when we're doing our cross. Cross says cross between a heterozygous tall plant. So the only one here that says heterozygous is the capital lowercase. So capital lowercase. And a homozygous dominant tall plant. So that's why I wrote these words here. So homozygous dominant tall is going to be capital T, capital T. When we go to fill in our Punnett square, we got to put a capital and then a lowercase, then a capital and a capital. Fill it in, we've got capital and capital. We're going to have capital lowercase. This will be capital capital. This will be capital lowercase. Now for the genotypes, we see we have 2 different genotypes. We've got capital T, capital T. There's 1, 2 out of 4, or 50%. Then we also have capital T, lowercase t, which is 2 out of 4, or 50%. Anytime you're doing percents, they should always add up to 100. So 50 and 50, that adds up to 100. For our phenotypes, we need to know, what is it going to look like? Now, all 4 of these have a capital T. So all 4 of these are going to be tall. We don't have any of them that are 2 lowercase t's. So we're going to say tall, 4 out of 4, or 100%. Okay? And the last one, problem 4. Again, this is a new problem, so we can't use the same key. In flowers, purple flowers are dominant over white flowers. So if we do our key, we can have capital P, that would be purple. We can have capital P, lowercase p, that's still purple. And then we can have lowercase p, which would be our white. And again, we can write next to this, this is our homozygous dominant. This is our heterozygous. And this is going to be our homozygous recessive. So when we go to do the cross, we have to read the problem, see what it says. What is the result of a cross between a heterozygous purple flower? So heterozygous, the only choice is going to be your capital lowercase. And a white flower. Again, white, the only choice is 2 lowercase p's. That's our cross. So we have capital P, lowercase p, and then lowercase p, lowercase p. We go to fill this in, drop down the uppercase, and keep lowercase, slide it over. So lowercase, lowercase, this is going to be uppercase, lowercase, and lowercase, lowercase. When we go to do our genotypes, we see that we have two different genotypes in here. We've got capital, lowercase. There's 2 out of 4, or 50%. And then we've got 2 lowercase p's. That's 2 out of 4, or 50%. And for our phenotypes, we have 2 possible phenotypes. We have purple. This is purple. This is purple. This is not. So purple, 2 out of 4, or 50%. And then we have white, 2 out of 4, or 50%. These two are white.